In the first exercise then say the number of integers x that satisfy the following inequalities. X squared minus 5x plus 1 less than 0 is, we know that. This exercise is not very difficult, but we have to know the complete square. Complete squares to make a perfect square binomial, but what works? Better than example. A squared plus 2ab is a squared plus 2ab plus 0. It's logical, but 0 can also be written as b squared minus b squared, because b squared minus b squared is 0. Now, a squared plus 2ab plus 0 is equal to a squared plus 2ab plus b squared minus b squared. And here is our perfect square binomial, a squared plus 2ab plus b squared. That is a plus b squared. Finally, having 2a squared plus 2ab is equal to a plus b squared minus b squared. This is a complete square. Well, now let's complete the square in our inequality. So, x squared minus 5x plus 1 less than 0 is equal to x squared minus 5x plus 0 plus 1 less than 0. 0 is 5 whole squared minus 5 whole squared. For to make the perfect square binomial, that is x minus 5 whole squared. Just in nowhere you can see, because x minus 5 whole squared is equal to x squared minus 5x plus 5 whole squared. Now, minus 5 whole squared is minus 25 divided by 4, and plus 1 is minus 21 divided by 4. We move it to the right, and finally we will have to apply the square root in our inequality. This is a complex concept, but let's remember that the square root of x squared is equal to the absolute value of x. Yes, it's a little hard to remember this, therefore I recommend that you write it to the down in your notebook. So, the square root of x minus 5 whole squared is absolute value of x minus 5 half, and the square root of 21 divided by 4 is the square root of 21 divided by 2. Now, our number line x is delimited for 5 minus the square root of 21 divided by 2 and 5 plus the square root of 21 divided by 2. The integers number that we have to find are here in x. But to find them, we have to know how much are these number words. So we know that the square root of 16 is less than the square root of 21, and the square root of 25 is greater than the square root of 21. Then, in our first case, we are going to suppose that the square root of 21 is approximately the square root of 16. And the second case, the square root of 21 is approximately the square root of 25. Case number 1. The square root of 21 is approximately the square root of 16. Then, x minus the square root of 16 divided by 2 is less than x, and 5 plus the square root of 16 divided by 2 is greater than x. The square root of 16 is 4. 5 minus 4 is 1. And 5 plus 4 is 9. 1 half is 0.5. And 9 half is 4.5. Now we count to the integers numbers. 1, 2, 3, 4. Then in the first case, there are 4 integers numbers. Case number 2. The square root of 21 is the square root of 25, which is 5. 5 minus 5 is 0, and 5 plus 5 is 10. 0 half is 0, and 10 half is 5. Now we count 1, 2, 3, 4. Then in the second case also there are 4 integers numbers. Finally, line 2 case have 4 integers numbers, We can say that our number line of x minus the square root of 21 divided by 2 and 5 plus the square root of 21 divided by 2 also have four integers numbers. The number of integers L that satisfy the following inequality: x squared minus 5x plus 1 less than 0 is 4.